Welcome to clickmyproject.com. Let's discuss the project about accelerated edge preserving image restoration without boundary artifacts. In this paper, accelerated edge preserving image restoration without boundary artifacts is proposed. Blur in the noisy images can be reduced by regularized image restoration method. It uses non-quadratic regularized like L1 and total variation regulations. This method assumes a circling blur can lead to wraparound artifacts along the boundaries of the image. Uses of non-circulant model leads to increased computational complexity. So we can go for the new method that combines a circulant blur model with a masking operator. This model resulted non-circulant, so we implemented the variable splitting and augmented Langerian strategies algorithm and alternative minimizing technique. A simple linear system for this minimizing technique can be solved by FFT. It results in improved image quality than circulant model. This is the flow of our process. First we load our input image with a motion and uniform blur with variable pixels. Then we will apply the variable splitted and augmented Langerian strategies algorithm. Variable splitting algorithm involves the splitting the original problem into smaller tasks by using auxiliary constraints variable. It uses the salsa split Bergman algorithms. It converges faster than MFIST. The proposed algorithm used is ADMM2, ADMM-B2. Salsa and split Bergman's algorithms used to decouple the regularization term that cause inner interactions. The inner interactions can increase the convergence time. This interaction can be clearly by introduced second accelerative variable. This algorithm involves separation of the blur and the masking operator, augmented Langerian strategies. This algorithm is used for This algorithm involves separation of the blur and the masking operator. Then this algorithm used for solving constraint optimization problems. It replaces constraint optimization problem by a series of unconstrained problems. Augmented Langerian method adds on additional term to the unconstrained objective. The additional term is designed to mimic a Langerian multiplier. It results augmented Langerian function as a output, which is easy to minimize as a cost function. Alternative minimizing technique. Then we will go for our alternative minimizing technique. The alternative minimizing technique results the cost functions from the augmented Langerian function. This minimizing can be performed non-iteratively using a soft thresholding or shrinkage rule. Then we will go for our cost function minimization FFT. It is an algorithm is used to compute discrete Fourier transform and its inverse. It is used to convert the frequency to time and vice versa. The cost functions from the alternative minimizing techniques that can be computed by FFT to get the restored image. Now let us see the execution of the process. First we select main1.m file and click run file. This is a MATLAB guide window designed for accelerated edge preserving image restoration without boundary artifacts. First we load our input image. These are the data set available for our process. First we load our input image. We can select any one of the image in our data set. Then we will go for applying pre-processing step. In the pre-processing, here noise is removed with the help of median filtering technique. Noise is nothing but some undecided information that contaminates on image. These noises are removable using some types of filters. Here we are applying median filter to remove the noises. Then we apply motion blur to applying the blurring effects in our input image. Then we will go for applying the circular model. Then it will be splitted each and every circulant model. Process is going on. This is the result for our circulant blur model. It will take some time. Then we will apply AMDG B2 restore SA and split Bergman's algorithms used to decouple to the regularization terms that causes inner interactions. The inner interactions causes increase the convergence time. This interaction can be clearly by introduced second auxiliary variable. This algorithm involves a separation of the blur and the masking operator. Augmented Lagrangian strategies. This algorithm is used to solving optimization problem. It replaces constraint optimization problem by a series of unconstrained problems. Augmented Lagrangian method adds an additional term to the unconstrained objective. The additional term is designed to mimic a Lagrangian multiplier. It returns augmented Lagrangian functions as a output, which is easy to minimize as a cost function. Then we will get the result of our proposed work. Then we will analyze these results. This is the MSA and BSNR values is displayed here. Our algorithm works in this manner.